So, given these rapidly evolving trends, what are some of the biggest challenges you see businesses facing when trying to implement AI solution, particularly with agents?
Well, the three big challenges are number one, complexity. Complexity continues to accelerate, especially as you look at agentic workflows, because originally, if we're looking at just a chat bot, it had its own kind of complexity. But then if you add an agentic workflow, and even if you're 90% accurate in terms of the application, after just a few steps, 90%, you're basically at a coin flip or worse. So how do you kind of manage that complexity? Secondly, it's about the skills gap, and it's a real challenge for organizations. IBM did a study recently where they asked practitioners, how confident are you in your AI capabilities? And 24% said they were confident. Now, they're the front line that's being tasked to do some of the work with this generative AI. And I mentioned the data, and when it comes to really getting the outcome that you want, there's a lot of knobs to turn. And there's a customization spectrum for LLM. At the very beginning, it's just prompts. What's my prompt structure, and which prompt structure gives a better result? And then it's how do I leverage my data? And there's pre-processing steps, and there's retriever steps, and there's different context windows and chunkers and so forth. A lot of knobs to turn, even if it's doing simple RAG. And then there's the model behavior itself, and the fine tuning and different approaches and GRPO, et cetera. And then there's the post training. So you've got this huge spectrum out there, and each step has kind of a different stack associated with it. Our focus is to provide a consistent interface, regardless of what you're doing, regardless of the knobs, and provide that make that kind of practitioner much more effective. Combination of automation, but also a combination of, if you're able to see multiple configurations running at once, you get a lot more insight. It's a lot easier to say, these are low performers. Let's stop. Let's kill those, not dedicate any more resources to them, and look at these high performers. Now let's clone and modify. Let's do some variations and see if I can't squeeze additional performance. Ultimately, what outcome engineering is about is trying to balance out what I'm trying to do with the trade-offs in front of me, because it's basically solving across a Pareto frontier. There's a lot of different combinations, and those combinations are going to give you a certain cost level, a certain accuracy level, a certain latency level, a certain risk level in terms of private information leakage or hallucination, et cetera. And so that's what makes this difficult, is how do you manage those trade-offs effectively, and how do you do so that's not challenging to some of these practitioners and not cost prohibitive, because you're trying to do a lot of combination checking.
For sure. So you've definitely highlighted the need for a different approach instead of just building agents. What else can you elaborate on what outcome engineering means to somebody that's getting started on their AI journey, or even somebody that's a little more advanced, and how does it address these challenges?
So, yeah, I don't want to throw another term out there, but outcome engineering is in contrast to kind of the state now, the typical state. It's kind of a vibe check. It's kind of a random walk. It kind of matters where you start. And sometimes that start point is you're asking, Claude, what combination should I put? And you're starting there, and you're doing a few configurations, and then you go, well, I guess that's the high point. And what outcome engineering, it's really trying to balance across, what are you trying to do with the permutations that you're selecting, and doing it in a way that's very efficient, and taking the information of not only what's working but what didn't work to inform the solution. And one great example is a customer of ours that was doing an AI application, and had done just a handful of configurations, and then with rapid fire in the same environment, the same resources, did 2,000 comparisons and got a high bar, and got the accuracy and the performance and the cost level that they were